Subscribe and hit the bell icon to never miss a video from Let Machine Talk. So in tutorial 5, we'll be going through the basics of Pandas. Let's start by importing the library. Pandas is basically used for all sorts of data manipulation, data wrangling. So you can find it everywhere in data analysis if it's been done by Python. So if you are importing the library, then import command is used, import and then the name of the library, and you can shorten it, basically abbreviate the whole name into whatever you like. I have used PD and its general connotation for same. So I'll be importing this. So now it's being imported. Then if I have to see what's all in this particular folder, then I can use the command like terminal commands basically here as well, just with the exclamation mark in the front and just executing it regularly. So you can see I have downloaded a housing.csv. This data set will be in the repository itself, so you can clone it from there. So this is Boston housing data set. I have taken it from Kaggle. And so if you want to read a CSV file, then you have this command pd.read_csv. There are other format as well in which you can read, such as JSON and Excel and like pretty much any format you can basically read it from. And I have used CSV here, so pd.read_csv. If your this notebook is in the same directory, then you just write the name of the file, or else you have to go into the other directory. So data equal to pd and pd.read_csv and then housing.csv. Then if you want to gather the information about data, then you want to know which column, how many columns are there, and what is the d type and everything. So data.info, and then you have to call that. So there are like these many columns: id, crim. So these are all abbreviation. I'll put the data description in the repository as well. You can check that out. It will be a text file basically. And how many of them there are? So 333 in total. And there's not any column or any value with null. So every value is filled. There's no null values in the data frame. This is called data frame. And then each column's data type is also stated, so it's int 64, float 64, and so on and so forth. So if I have to display first and last x rows of the data, then head and tail command is used. I've put x equal to 3. If you don't put anything, it will display the first 5 and last 5 respectively. So I'll go ahead and execute that. You can see that there will be 3. So indexing in this also starts from 0. And if I will do this, then I'll see the last 3. So to gather the column names, it's useful sometimes if you have to iterate through the columns in a for loop or in any kind of operation that you're doing basically. So if you have to store only the column names as a list, so you can do that and use it as a regular list. So if I'll do that, then I'll have the first 4 column names. You can see first 4 column names were id, crime, zn stands for zone, and indus. So there they are. And then if you have to accept it separately, so that you can do that as well. And then if you have to rename the column, then make a list of the names you want to replace existing names with. So I have described this name as column_new, and then all the names. So I changed crim to crime rate, then zn to zoned, and so on. And then I'll just do data.columns equal to column_new. So this will change the column names. So you can see now, zn is become zoned, and crim is become crime rate, and etc. So you can do that according to your comfort. Then if I have to access the values of a particular column, then I can do the data, and then in place of index I'll put the name of the column. So this I'll do. If you don't have any gap in between these two letters, then you can use data.median underscore price as well. This gap you can't do that. Then if you have to access multiple column, so pass it as a list in square brackets of the column name that you want to select, then treat it just like another data frame. So data and age, crime rate, and then you see here it's a list, and you can define it separately and then pass it as well. So data, and then I'll put a head, so it will return the first 5 values. And then if I want to access certain index values, so I can use this like we used in list, and whatever index you would like to place. So I've selected first 10, so there they are. If I want to select like from 5th to 10th, I can do that as well. Then for the row selection, if there's a command called ilock, so here it will select all the rows from 0 to 10. So, and you can customize it according to your needs. So basically, then if you have to remove a column, so then just type del data and then no, like I have selected this column to be deleted, and just go ahead and do that. You'll see that here no concentration was there and here it's gone. So if you want to add a new column, then you simply type data and the new column's name and the values to be passed. So I just selected one string, so it will copy it all to all the rows. So if I'll do this and check them, so it will copy test to all the rows, and you can pass a list as well to store that. Then I have if you want to remove rows, then x is 0 is termed to be rows, and if you want to delete a column, then you have to put x is equal to 1 and then here the column name. So if you want to remove a row, then data drop and then index number and in place equal to true. So if you do that, then it will remove the rows. So if I now do from 1 to 12, you can see the 10th is missing because we dropped it here. Then if you want to drop multiple rows, then the same command, and instead of just 10, you can pass what index you like to drop. So if I do this, and in place is basically that when you'll execute this, it will change in the main data frame, and if you don't do this, then it will just display the result and it will not actually make changes to the actual data frame, the original data frame. If you do this, see, you can 1 2 3 4 are gone now. So then selecting rows according to certain conditions. So suppose if I want the data of houses near Charles River, this column here, Charles River, it indicates whether the locality is near Charles River or not. So 1 indicates that it is and 0 indicates that it is not. So if I want the data of houses near Charles River, so I can put this condition, so data, and instead of index you can put a condition here, so data dot Charles underscore river equal to 1. So this is the condition. If you do this, and then if I have to now find, if I have to only get the price, or let's say median price and distance, then I'll do this, and how regularly you select the columns, and then head 5. So I selected distance and median price from the houses which are near Charles River. Then 2 conditions, if I want to put 2 conditions, suppose I want the locality which is not near Charles River and not near Charles River, and the crime rate is less than 1. So I'm searching for locality which is less expensive, basically if the Charles River area is more expensive and the crime rate is low. So I'll go ahead and put the same condition. So it is now a data frame till here. Then I'll access again with an index with the second condition, so data dot Charles underscore river equal to 0, and then the second index will be data dot crime underscore rate less than 1. So if I'll go ahead and shift plus enter, so it will display only those which are not near Charles River and the crime rate is less than 1. So this is a little code that I wrote. This is matplotlib. We'll go dive in the matplotlib later on. First, so I'll go ahead and do that. So this is basically, it's showing price versus distance. This is just a general graph. We can I'll show you how to do this in later section of this series. Then using help function, so help plt.plot. So I imported matplotlib.pyplot as plt. So if I want to know that plt dot what this function can do, I can simply type help and then plt.plot. So it will tell what arguments to pass and stuff like that. So and just if you want the statistical description of the data, then you can just simply type data.describe and call it. So you'll get the count, mean, standard deviation, minimum, maximum, 25% quartile, and 50%, 75%. So you'll have the first and second and third quartile and everything for every column basically. So, and if you have to find out that is there any missing value, so if you'll just do this, so it will state all the values where it's false or it's true the condition. So is null, basically you're asking that is that particular position null. So these all are stating that no, it is filled up, and so thereby displaying false. And then if you want to draw the correlation matrix, then data.corr and then call it. So you'll have a correlation matrix here. So each variable, the correlation between each variable is given here. So if you want to know the data types of all the columns, then you can do data.dtypes. As soon as you do that, you will just get the d types. It's from their info as well, so hardly matters. And then if you want to have the dimensions, how many dimensional your data frame is, then you can type data.ndim. So you can see here it's 2-dimensional. Then if it's not null, then if you want to pull out the values of a particular row, that whether a particular column values in a particular row are not null, so you can do that, or is null, you can do that as well. It will tell you all the values. So all the values are true, that means it's not null. So going further, we'll discuss something more about pandas. Please check out for the part 2 of this video. Thank you for watching. Please like, share, comment and subscribe. I'll put the link of the GitHub repository in the description. Thanks for watching.